Hello, our friends. In the past 3 days, ever since we decided to drop FPGAs, we've had time to reconsider our approach. We've been going through the Data Parallel C++ book and have just finished it, so we are itching to try it out on a real project. Regarding our behavior, to put it bluntly, we are crazy. We've been obsessed with AI chips for the longest time and have spent a significant amount of time working on our own language Spiral, just to make it easier to use them. When they didn't arrive on the schedule we wanted, we didn't take it well. One consequence of that is what you saw in this series, an ill-considered foray into FPGAs. We did all this work, and while we did learn the semantics of how FPGA high-level synthesis works, and expanded the Spiral language so it now has type-level arithmetic, as well as created the C++ backend, our shot fell short of reaching our goal. This is much like how it was in the past, and we keep moving from failure to failure. We think that our attitude is to blame for all of this, so we will change how we operate. You have to understand, when we say that reinforcement learning is garbage, ultimately our opinion of it is colored by our experience, and our experience greatly depends on the hardware resources we have at our disposal. We mean, it is bad objectively, and can't be expected to perform well in the real world. But poker is hardly a real-world use. Even deep stack no-limit hold'em is just a toy game in the grand scheme of things. Sure, the current crop of reinforcement learning algorithms do have issues with credit assignment, and backpropagation-based neural network models have zero ability to learn over long timescales. They will be replaced in their entirety at some date. But that is not the point. Every ML expert is aware of those issues, and yet deep learning continues to be used. We cannot improve the algorithms themselves right now. Even if we understand the issues, we lack the power to reach into the ether and pluck out the solution, much like everybody else. But that is no reason to turn our back on the world and abandon the current-day algorithms. So, to make our next attempt work, we will go back to the basics. Forget AI chips. Compared to our aging rig and the GTX 970 GPU, the server-class hardware has hundreds and even thousands of times more compute power. And we have the programming ability to implement the ML models as well as completely parallelize the game, both on the CPU and the GPU. It doesn't matter what hardware we have. Our responsibility should just be to maximize its utilization. Recently, we've discovered something really good in the form of Intel's Dev Cloud for OneAPI. The nodes there have 192 gigabytes of RAM at least, so we'd be surprised if the core count for them was less than 48. In terms of hardware, that should be enough to start us off on our journey. In terms of software, we've discovered the Data Parallel C++ language, and the great thing about it is that it will allow us to implement the program in such a way that full utilizes the available hardware. Furthermore, Intel also provides many open-source libraries that we are interested in trying out. At the foremost of our mind is OpenVINO. That particular ML library is mostly used for inference, which suits us very well. Though we will be training NN models, we'll be doing those using evolutionary algorithms, so if the quantization processes it is offering are fast enough, we'll make them a part of our training pipeline. Later, to get the absolute best performance from our devices, we will be redesigning the hand ranker as well as the game, so they can be run on the GPU, without the very costly operation of having to move data back and forth to the host. It stands to reason that this would work, even if GPUs would be very slow at running a single instance of the game compared to the CPU. We could run hundreds of thousands of them in parallel for something like no-limit hold'em, and that is just on the GPU. Later this year, AMD will release the MI300 chip, and Intel is coming out with Gaudi 3, which are rumored to be technically superior to even the H100 card by NVIDIA. We don't know the specs for Gaudi, but AMD's chip has shared host device memory, which would eliminate the costly data transfer issues between the CPU and the GPU, so we'd be able to use CPUs where they are most appropriate, such as for running the game logic, for example, and the GPU parts for the NN models. Most likely, we'll be able to program them both using Data Parallel C++. Hardware development is going to go in that direction regardless of what the floundering hardware startups do. The time goes on, but what we will do in this series will be for the ages. Let's end the video here. We need to overcome our own insanity and get more in tune with how AI actually works in the real world. We'll overcome our obsession towards AI by finishing the near-decade-long poker project and update our skills to the latest era. By the end of it, we'll be able to do anything in ML. A lot has happened since 2015. The world has changed, and we need to change as well. On this path, functional programming will be our constant companion, so let's get back to it.